friend.
Hey, how's it going?
Good. How are you doing?
Yeah, I'm pretty good. How about yourself?
Good.
That's good.
I had to go way back on my phone to find you.
Yeah, it's been a while.
February. So, how's the math going? What are we going to work on tonight?
It's coming alright. So what we've been doing recently in my math class is we're done with like the pre-calc part of the class, and now we're doing like a calculus sort of like quick study for next year. And these things are based on the homework. You don't have to turn in the homework. And then we have these little calculus quizzes at the end of every week.
Okay.
And they're just based on the stuff that we've learned in class.
So you on limits or derivatives or?
No, yeah, we're on the product rule and the quotient rule. So
Okay.
using derivatives to get those.
Okay.
Yeah. Mm-hmm.
Well, do you have some specific problems?
Yes, I do. So a lot of these involve square roots because I'm kind of shaking and stuff.
Okay.
So the first is going to be root x times 1 minus x squared. And it's just use the product rule.
Okay. The best way to always write radicals when you're doing calculus is to convert them to an exponential form. So what's the square root of x equal to?
Isn't that like 1/2 x to the power of 1/2 or something? Sorry.
X to the 1/2.
Yeah.
Once you've expressed it this way, now you can use the power rule to do these. So y prime. You can go either way, but the way I generally teach people to go is do this times the derivative of that as your starting thing.
Right.
Okay, so x to the 1/2.
Yeah.
What's the derivative of this?
Would that just be negative x? Or?
Negative 2x.
Oh, sorry, yeah, sorry.
You got to bring that exponent down in front of that and reduce it by 1. So the derivative of that is minus 2x plus this times the derivative of that. So 1 minus x squared.
This is where it gets confusing.
Well, always start with the exponent.
Okay.
Take the exponent and multiply it by whatever the coefficient is.
So that'd be just 1/2 x.
And now subtract.
Oh, and then isn't this negative 1/2 to the power of negative 1/2? Okay.
In other words, that's all you do to apply the power rule. Is you multiply the exponent by the coefficient, which in this case was 1, and then subtract 1 from the exponent.
Okay. All right.
So this is what we get. There's still a lot of simplification we could do to this. I don't know how far they want you to simplify it. Do you have answers on these?
Well, I can go to the back of the book and check, so let me do that.
Yeah, let's find out how much they want to simplify, because we can do some simplification. Obviously, we have an x to the 1/2 times an x, so we can add those exponents.
Yeah.
Let me go ahead and do some minor simplification.
All right, so this is interesting. What they're asking for is 1 minus 5t squared, x squared, divided by 2 root x.
Okay, so we're going to the next problem.
I guess they're wanting quite a bit.
Hold on one moment. This is the answer they're giving to this problem?
Yeah, the one I just said.
What is it?
1 minus 5x squared divided by 2 root x. Yeah.
Okay. Well, let's see if we can come up with that.
All right.
We've got this part of it. In other words, I multiplied those two together.
Right.
And now we're going to add 1 minus x squared, 1/2 of that, And this I'm going to put in the denominator as x to the 1/2.
Oh, you can just bring that to the denominator if you change the sign?
Yep.
Okay.
Yep. And likewise, if it's in the denominator and a negative, you can take it to the numerator by changing its sign. In other words, you can also always take it to the other side of the fraction bar by changing the sign on the exponent.
Oh, okay. All right.
Yeah, I mean, let's just go over that. 2 to the minus 3 is equal to 1 over 2 to the 3.
Okay. All right. That makes
If
sense.
you have 1 over 2 to the minus 3,
that'd just be 2 to the power.
Exactly.
Yeah.
In other words, just whenever you take it to the other side of the fraction bar, change the sign on the exponent. And that's essentially what negative exponents mean. They don't mean negative numbers. In other words, 2 to the minus 3 is 1/8. That's a positive number. So negative exponents rarely mean negative numbers. Just mean reciprocals. All right, so let's go back to this one and see how they end up with 1 minus 5x squared. Well,
all right, so I don't know where they're getting the 5 from. I think is my biggest confusion on this.
Yeah. Well, if we're going to add this fraction to this fraction, then we need a common denominator.
Oh, okay.
Okay. So, what's our common denominator going to be?
This is for the second part, right? The 1/2 times 1 minus x squared.
Well, we're adding this to this whole thing.
Okay. Oh, so we're going to need x to the power of 1/2.
Right. That's going to be the common denominator. Okay, so I'm going to put an x to the power of 1/2 there. What do I need to put in the numerator?
Well, you'd want to multiply that by x times, or x to the power of 1/2, right?
Which becomes x squared.
Okay. Oh, because it's 4 over 2. Yeah.
Exactly.
Okay.
Okay, so this is the same thing as this. And that's what you always want to make sure you don't ever change it. Okay?
Okay.
So now we have that plus the 2 goes in the bottom. The top is just going to be this.
Okay. All right.
Now, since we want a common denominator, let's make this 4 and make that 2, like that.
All right.
Now, can you see where the 5's going to come from?
Oh, yeah, because it's going to be 4x
First,
squared.
we're going to make that x squared. And our common denominator is 2x to the 1/2. And what do we have? We have minus 4x squared plus another x squared. So that's minus 5x squared. And there's the 1. Yeah. So it's 1 minus 5x squared all over 2x.
And that's root x.
To the 1/2. And x to the 1/2 is the same as root x. So that's how we come up with that as an answer. Okay. The toughest thing about calculus is the hard algebra more than the calculus. In other words, applying the power rule and the product rule and the quotient rule are just memorizing them and plugging them in. But the hard part was once we came up with the answer, figuring out how to simplify it. That was some fairly difficult algebra.
Yeah.
Not terribly difficult, but fairly difficult.
Yeah.
All right.
Okay. So the next question I have is on the quotient rule.
Okay.
So I already did one quotient rule problem that reads x squared plus 1, but this one is x over root x minus 1. So this is a different problem again involving square roots.
All right. What have they taught you as to how to memorize the quotient rule? And do you need to have it?
Well,
or are they going to let you use a cheat sheet?
I honestly don't know because I was taking an AP test while they were taking notes on this subject, the quotient rule, in my math class. So I kind of don't know very much about it except what's in the what's in the
Here's
book.
what it is.
Yeah.
Starts with the bottom.
Okay.
The derivative of the top minus the reverse.
Minus the top derivative of the bottom.
Right.
Right.
All divided by the bottom squared. Okay. Now, the order on the numerator is important because we're doing subtraction. It's not like the product rule. The product rule, you can reverse these two things because addition is taking place. So on the quotient rule, it's absolutely important that this left entity here be the bottom times the derivative of the top.
Okay.
You can't reverse these like you can with the product rule. Okay? So this is it, and the way I memorize it is I start with the bottom and end with the bottom squared.
Okay.
That's a good way, because if you start with the bottom, well, this has to be the derivative of the other, the top. Subtraction is taking place, because we know the order of the numerator is important. And this is just the reverse. Always is the reverse. So this has to be the top times the derivative of the bottom, and end with the bottom squared. So if you start with the bottom and end with the bottom squared, you're going to get this part right, this part right, this part, and this part.
Okay.
Okay?
All right.
Start with the bottom, end with the bottom squared. So, I'll leave that up there for the moment. So, what's the bottom?
Well, that's going to be root x minus 1, and the derivative of the top is going to be 1. So just root x minus
1 inside the radical or outside?
Wait, what's up?
Is this minus 1 inside the radical or outside?
Ooh, I'm going to go with...
Is it the square root of x minus 1 like this?
Oh, wait, no. It should be outside. Well, actually, I don't think it matters, does it?
Well,
because the root of 1 is 1.
Well, it does matter, actually.
Oh,
Makes a lot of difference. Yeah.
It should be outside.
Okay. Well, we're going to assume that it's this way. Okay. So there's your bottom.
Okay. Right. Yeah. Right.
The derivative of the top is, like you said, 1.
1. Yeah.
Minus the top. Now, what's the derivative of the bottom?
That would be 1/2 x to the power of negative 1/2, right?
Yes.
Yeah. Okay.
And then the derivative of a constant is 0, so, and then all over the bottom squared. What's the bottom squared?
It's going to be x minus 1. Oh, wait, no, do you have to FOIL it?
Exactly.
Okay. Yeah.
So the first term is going to be x. Then we're going to have minus
2
x plus 1.
Plus 1. All right.
Okay. So there's our answer. Now,
but now the simplification.
Right, and that's where it gets hard. In other words, that's the easy part. That was just plugging in.
Yeah.
So, let's see. What can we erase? We can erase that. This, we're going to have to do some sort of common denominator.
Mm-hmm.
So,
all right.
Let's tackle that. Let's see. We have root x minus 1 minus... Maybe we don't have to do that common denominator. Notice that if we distribute this x times x to the minus 1/2 is x to the 1/2.
Oh, because it moves up a full interval. Right.
Exactly.
Okay.
And I can rewrite this x as x to the 1/2. So there's our new numerator.
All right.
Well, x to the 1/2 minus 1/2 x to the 1/2 would give you 1/2 x to the 1/2 minus 1. That's our new numerator.
Oh, because it's taking away. All right.
Yeah, I got a whole x to the 1/2, and I'm subtracting a half x to the 1/2.
Half x.
1 minus a half leaves a half. Okay? And
a lot of this is basic math concepts, but integrated in a way I wouldn't expect it.
Yeah, like I said, this is hard algebra, but very doable. And so if I want to get rid of this 1/2, I'm going to need a common denominator. So let's make it 2. I'll make that 1 look like that.
Right.
And now the numerator looks like this. I'm going to write it over here on the left. The numerator looks like x to the 1/2 minus 2 over 2. Okay?
Okay.
So I've simplified what we had there. The denominator is still x minus 2 x to the 1/2 plus 1. We know that's x to the 1/2 minus 1 squared.
Oh, man.
I can move this 2 down. In other words, this 2 right there, I can move down 1. In other words, to the denominator.
Okay.
Let's see what happens if I move that 2 down and we unsquare this and put it back in 2 times x to the 1/2 minus 1 squared. That's the way it started.
Okay.
Okay, and now I can erase this fraction bar. And that's the point I'm at right now. Question is can we do anything with this x to the 1/2 minus 2 combined with this x to the 1/2 minus 1? And the answer is no. No more than you could do anything if I had...
Is that because it's squared?
If I had something like this, I could not simplify it.
Oh, that's true. Okay.
So the only way I could do anything with this is if this is the same term as this.
So this is as far as it goes? And
I think so, yeah. Okay. I can't see any other way to simplify it.
That makes sense.
Yeah, I might have made a mistake in the algebra. That's the problem with these, is that the algebra is so difficult that it's really easy to make a mistake along the way.
Yeah.
And then you never find it. I mean, if this is not the answer...
For me, it's more about just...
Well, I'm saying that if you looked up the answer and this wasn't it, then I would have to retrace my steps and go all the way back to the beginning and see if I could figure out where I made my mistake.
Right.
It's possible.
I mean, I think my area of help lies not in like the algebra being all correct, but just understanding the general concept.
Okay, cool.
So I think,
cool.
Yeah.
All right. Well, there's the quotient rule and the product rule. Have you had the chain rule yet?
Okay. If I do, I haven't gotten to it. There is one other thing that I had a question on. And this set of problems asked me to find the derivative of x and the derivative of c.
Okay.
And it gives, as the function, it gives x plus 5 over x minus 5, and the value of c is 4.
X plus 5 over x minus 5.
Over x minus 5. And then the value of c is 4.
Well, first of all, where is c in this equation?
Oh, wait.
In other words, I don't understand.
I see, neither do I. That's why I asked. I don't know.
We can certainly find the derivative of this function. It's easy enough to do.
Yeah, wouldn't it?
Well, let's apply it. Let's start doing that. So.
That would just be 1 over 1, right?
No. Remember, we have to apply the quotient rule.
Oh.
So we have to start with the bottom and end with the bottom squared.
Alright.
So
x minus 5.
There's the bottom.
And then times the derivative, just 1.
Okay.
And then minus. minus x plus 5. So it's just x plus 5, or x minus 5 minus x plus 5.
Right. All over.
And then over x minus 5 squared.
Okay. Now, the numerator, notice, simplifies quite nicely.
Yeah.
We end up, I don't need these parentheses at all. Yeah. This minus 5, we got an x minus an x. So we have minus 5 minus another 5, which becomes minus 10 over x minus 5 quantity squared. There's your answer for the derivative of this function.
Okay.
Now, as to where c goes, I don't know where c started. You got to tell me where c started.
And I have no idea. I'm looking at the set of problems, and I'll just read it all out.
Okay.
In exercises 13 through 18, find the derivative of x and the derivative of c. It has a sign saying function and a line, and then under it is the function itself. Then the value is over here, or sorry, it's like over to the right, and it says value of c, and it has a bunch of c values listed, and for each problem. And this one says 4.
How quick can you take a picture of that and send it to my email?
Probably not very quick, seeing as I would have to use my mom's phone because mine won't do that. It doesn't have that.
Okay.
So
it might help
and these
understand it if I could see it on paper.
Yeah.
I'm still confused. I don't know. In other words, finding the derivative of this function is easy.
Yeah. Mm-hmm.
This is what it is over here circled. But when it says find the derivative of c, c is normally a constant. And the derivative of all constants is 0.
Oh, yes, that one makes sense.
It doesn't seem like that's what c is here. I don't know what it is, but...
And the only location of c is a place where it tells me its value. That's the only place I can find a c value. That's the only place it's applied in. I guess I would say.
And it said find the derivative of x. Yep. Well, what does that mean? Does that mean dy dx?
I would guess so because, well, before each thing, like before the x plus 5 over x minus 5, it had the f of x. And it asked you to find the f superscript 1 of x.
Okay, f of x would be like that. Is all that means is that's the same as y, only it's more information. It says we have a function that is only x, is the only thing we're going to find on the right side of that equation. So I can write this as f prime of x. That's what first derivative means. That's what that superscript means. Okay,
right, so,
now where c comes into it is where I don't know.
These don't make sense to me.
Let's talk about notation. All of these things mean the same thing.
Okay. Oh my God.
All 4 of them mean exactly the same thing. Y prime means first derivative. F prime, same thing. Dy dx means I'm taking the derivative of y relative to x. I could also take the derivative of y relative to another variable that's not even in there, like t. And maybe that's what they want, is the derivative of y relative to some c. In other words, when I wrote f prime of x, I could also write that dy dx. This quantity that we came up with, minus 10 over the bottom squared, that's dy dx.
Right.
If I wanted dy dc, I could come up with that, even though c is not in this function. It's a variable that isn't there, which means every time I run into x, I got to follow it with a dx dc.
Okay.
But that to me seems like it's a little complicated. You're not going to be there yet if you haven't come up to the chain rule yet. In other words, the progression of calculus is such that if you've done the product rule and the quotient rule, but not the chain rule, you got to be right in there. And implicit differentiation, which is what we would be talking about, comes after that.
Okay.
And so I don't think you're talking about implicit differentiation.
Yeah, probably not.
So the only thing I know how to tell you to do here is how to come up with dy dx or df of x dx.
And these problems aren't mandatory for me to do. It's not like I'm turning them in for a grade, so I don't actually need to know that specific
All right.
thing.
Well, I'm more curious probably than you are. I'm trying to understand what they're talking about, why they would have this other variable c involved, unless it was something like plus cx, and you know the derivative, and then you can have to figure out what c is to, you know what I'm saying, something like that.
Yeah, I do. Right.
But it doesn't sound like that's what you're talking about. Well, we got a few more minutes here. What last thing would you like to cover?
Actually, that was all I really had in mind. That was all that was giving me problems.
Let me just see if you've done the chain rule. Give you a function that would require the chain rule. Have you done derivatives of trig function, John?
Oh, I don't think so. And again, I missed that class period, so I'm not entirely sure what we're doing as of right now, but...
If I were to try to differentiate this, I have to apply the chain rule. I can start with the power rule by taking the derivative of the outside, like that. But then I have to multiply it by the derivative of the inside, which is 2x. So that's the chain.
Oh, that got messy real quick.
If you've had the product and the quotient rule, I suspect you probably have had the chain rule also. They generally all go together. The chain rule is the only one that's hard to understand. But the primary effect of the chain rule is you have to, when you have a composite function, this is a composite function. It's made up of y equal x squared plus 2 and another function that's square root of x. Put those together and you end up with that. When you have a composite function, you have to apply the chain rule. You have to take the derivative of the outside and then you have to multiply it by the derivative of the inside. And it can get very complicated. Sometimes you have to apply the chain rule twice or even 3 times if you have a very difficult, complicated function. So the chain rule is much harder to understand than the product or the quotient rule. Product, quotient, and power rule are just memorizing it and plugging it in. Chain rule requires a little bit more. It requires you to understand what the inside is and what the outside is. Some functions it's easy, but others not so.
Right. Okay. Alright, this is making a little more sense now. Yeah.
Okay. Alright. You good to go, Brent?
Alright. I think I should be good.
Okay, if you need any more help, by all means call me or
I'll let you know.
schedule it. I love tutoring calculus. To me, calculus is more fun than any other math.
Yeah, that's what our math teacher says.
Yeah,
too.
once you've studied calculus, nothing else compares. All right, Brent. I will talk to you next time.
Thanks for your help.
You're welcome.